So in part D, we come up with some kind of general expression to find the nth derivative of f of x, which is e to the power of x times sine of x. Okay. So from part A, B, and C, we noticed some interesting patterns. Okay. And really, the patterns really depended on what kind of derivative n was. Okay. And what I mean by that is, let's take a look at all the derivatives that are a multiple of 4. So f of f, the 8th derivative, the 4th derivative, and the 12th derivative, okay, of x. So we saw that the 4th derivative was negative 4 times f of x. The 8th derivative was 16 times f of x. And if you carry on with the rule and differentiate all the way to the 12th derivative, you're going to notice that the 12th derivative is negative 64 times f prime of x. Okay. So what this tells me is when n is a multiple of 4, say 4 times k, okay, then in general, the nth derivative, or the 4k derivative of x, will be equal to negative 4 to the power of k times e to the x sine x. Okay. So the first one here, the first term, when k is equal to 1, we're going to get the 4th derivative. Okay. And evaluate the k and you get this expression. Do the same thing for when k is equal to 2, okay, we get the 8th derivative and we get this expression, and so on. Now we can do a similar thing to come up with a pattern when n is equal to a multiple of 4 plus an extra number. So those are 5, the 9th derivative, and the 13th derivative. Okay. So in part ABC, we saw that the 5th derivative was equal to negative 4 times f prime of x. And the 9th derivative was 16 times f prime of x. And if you continue and manually differentiate the 13th derivative, you're going to see that it's equal to negative 64 times f prime of x. Okay. So from this, we can come up with an expression for all derivatives that are a multiple of 4 plus 1. Okay. And all of them, the general term for all of those derivatives will be negative 4 to the power of k times f prime of x. And f prime of x we found in part A, right? F prime of x is simply e to the power of x times sine of x plus cos of x. Now you can do something similar, okay, for all other derivatives that are 2 units more of derivatives than 4k, and you're going to see a pattern developing very similar to the first 2 patterns we've noticed. And you can do the same thing for 4k plus 3. Okay, and there you have it, the general terms, okay, to compute the nth derivative of the function f of x is equal to e to the x times sine of x.